Alright.
Sometimes I wonder if people
Let me know if the streaming is actually okay.
I mean, how is that possible? For years, I've found myself in the same position, loving the same person, feeling that love so deeply. Maybe I need to forget it, just move on and be like everyone else.
One sec. Be right back. This is going to be some nerdy ass shit. Alright, I'm gonna start in 3 minutes. Alright, testing 1, 2, 3. Alright, testing 1, 2, 3. Alright, we're gonna start in 2 minutes. I feel like shit. How's my stream health though? Is it okay? Let me check something. I'm gonna do 2,000 actually. Let's just do that. It's not gonna be even really like. I don't even really need that streaming speed power anyways for this thing. Okay, 7:05. I think we're just gonna start. What's up, y'all? How's it going? I don't think there's anyone watching me right now. So this is what I'm going to work on today is called the Pokemon Weedle's Cave. What this is that this is before like we get into the specifics of this thing. I know this is Pokemon and this is like weird. I'm like, what the hey? What we're doing is actually we're just gonna figure out a simple Kaggle dataset and just do a simple analysis on this for today. And when I be my simple, I'm a noob, so it's not gonna be simple for me. So we're just gonna start out by just working on this, man. What up, Jason? How's it going, dude? How you doing? Can you hear me? What up, man? How you doing? Thanks for stopping by, dude. Yes, you see Pokemon's Weedle's Cave. So this is Kaggle. Kaggle is a website where it's basically a repository of all these like data sets that a lot of organizations, companies, even users like create a data set. And what people do is to just try to meet the objectives of depending on certain data sets. So for example, for like this one, this is a Pokemon data set. Weedle's Cave. Welcome to Weedle's Cave. And what we're gonna do is that, will you be able to predict the outcome of future matches? And so you just download like a data set. It's gonna have certain types of information in here, right? So he gives us like three different files and stuff like that, or this Kaggle thing gives us like 3 different Kaggle sets. What up, Jason? Yeah, thanks a lot, Jason. It's like an Excel spreadsheet, but not really. It's a CSV, comma separated values file with only like basically three columns. The first Pokemon is like the first Pokemon that starts with all the unique IDs that relate to a Pokemon. So Pokemon ID 266 references some specific Pokemon. So is this one. So basically what they're doing is that they're battling each other. Pokemon number 266 versus Pokemon number 298. So who won against that battle? Pokemon 298. Pokemon 702 versus Pokemon 701. Who won? 701. So we have the existing data, but what can we do to actually create an algorithm or a model to know what kind of what is the most probability, what's the probability of the outcome of certain Pokemons? So this is the overview. Mind you, this is not an actual Kaggle challenge, like an actual Kaggle competition challenge. It's just a warm-up. The competition overviews are way more complicated. Maybe not way more, maybe just somewhat more. This is just a more simplified version of it, man. And also, Jason, man, like, let me know if you have questions, dude, or if you want to hear something. I hope Kathy's watching me. What up? And Grayson. I should not say their names, huh? Anyways. My bad. It's not like anyone else is watching, really. And if you want to say something, say it in the chat or something else. Right, we're gonna get to that, Jason. How can you use the data? There's a bit of a lag anyway, so it probably takes like 30 seconds for me to actually respond, because the actual chat pop-up comes like 30 minutes after you type. 30 seconds, excuse me. Yes, build an algorithm. It's a machine learning algorithm to predict what kind of Pokemon will win. This is gonna be like I guess a part series, because I don't think I'm gonna finish all this in one day. Because there's a lot of elements, a lot of things that we need to do. Anyways, we're gonna start. Alright, here's the overview. Welcome to Weedle's Cave. Will you be able to predict the outcome of future matches? So that's basically the overall challenge. Like, let's say you're in a business setting for some reason, and like for some reason you kind of want to predict something. Like predict this a Pokemon future matches. Just try to like imagine that in a real world setting, corporate setting or something. To do it, you will have a Pokemon characteristics and the results of previous combats. 3 files are available. The first one contains Pokemon characteristics, the first column being the ID of the Pokemon. The second one contains information about the previous combats. The first 2 columns contain the IDs of the combatants, and the third one of the ID is of the winner. The Pokemon in the first column attacks first. The goal is to develop a machine learning model able to predict the results of future Pokemon combats. Before we actually get to the machine learning model, we gotta actually look at what the data looks like. So here's what we're gonna do. Let me know if you have any questions, Jason. If you have anything like, if you're like already lost or something like that. But I've already downloaded the data files, so we're gonna actually open this up. I've already created some stuff already right now. So actually, you know what? I'm gonna start over. Let's see here. Alright, what we're gonna do is, okay, so we're gonna look at this. The goal is to develop a machine learning model that's able to predict the results of a future Pokemon combat. By the way, this language is R. R is a statistical program language where you can like do data munching and programming. It's basically a one of the data scientists' most popular languages. Other being Python, obviously. Python is actually slightly a bit more popular, but R is actually specialized in statistical programming and stuff like that. Yes, exactly. The calculation can only be done with the data that is picked up. Yep, that is very correct. Otherwise, we need data in order for the machine learning algorithm to get a sense of how the battle is turned out, and then based upon the data that we fed into that algorithm, it'll then calculate the prediction of any future Pokemon predictions and stuff like that. I will get to how in a moment, but first, as a data scientist, what we need to do is that we need to really know our data first before we even actually build a model. So number one, exploratory data analysis. That's the very first step. I think this is something that we need to work on first before we actually get into the algorithm first. Number two, clean up or restructure some data once we find out what we want to do with the data. So in a real life setting, this is actually way simpler. It's way simpler than an actual corporate setting and stuff like that, because the data is already structured. We have simple data. In the real world, trying to get the right type of data, the enough data to find out like which type of data is actually way more important in a real world setting than what we have in Kaggle. But fortunately for us, Kaggle is like a little bit easier. We already have like structured data set up in the first place. Those 3 files, remember? Anyways, after we do some EDA, we clean up, restructure some data. Number 3, then we do if any pre-processing necessary. Pre-processing the data necessary. I'll get to what pre-processing means in a minute. A little bit later, I mean, not in a minute. Then we do the machine learning process. Because actually, no, wait. When we clean up, restructure some data, once we found out what to do with the data, we pick the most appropriate machine learning language, or not machine learning, machine learning algorithm, excuse me. Once we pick up the most machine learning algorithm, now we can do some pre-processing with the data, and then we can just do the machine learning part, and then after that, we do evaluation. And I will definitely get that soon, a evaluation or assessment of the accuracy of the model. Sometimes, maybe even creating a machine learning algorithm might not even be the most appropriate method, but we don't know yet unless we do some EDA first. EDA is always going to be the most important thing. Can you guys see this? Can you create a platform to collect data, or is the data you leverage always in conjunction with some type of software? Yes, in a real world setting, depending on how the company is structured, collecting data is actually a very crucial part. That also means that you might have to, if in a corporate setting, if a company hasn't started out with anything, hasn't any structure of how to collect data in the first place, that's when you do that part first, the phase part of where you need to figure out what is the most appropriate way to actually collect some of their data. Unfortunately, we can skip that step in Kaggle because Kaggle, we already have data for us and we just analyze it. The data is always in conjunction with some type of software, yes. It could be any type of software, it could be Excel, but you could even just like for like new companies that start out, it could be like just dirty data where a human being can just write some data stuff in Excel, and then you have data. You might not have a lot of data, but I mean, it's not as efficient, but you have data. But mostly, like, usually, practically speaking, there's always going to be software that churns out certain types of data. Fortunately for us, again, in Kaggle, we don't have to worry about this part because we already have the data that's already like generated for us from someone, and I guess it's from the Pokemon Challenge by Intelligence. I don't know. This is already like a very old Kaggle thing, but anyways, let's get to it. EDA. So number 1, exploratory data analysis. This is kind of technical, but right now, this is R. R is, I think I already told you what R is. It's a programming language that actually revolves more around statistical concepts. So what we're going to do is import the data into our program. So what we're right now, we're going to have to figure out where the data is located. Fortunately, the CSV files, combats and Pokemon that I downloaded from the Kaggle website is in my folder here. So we're gonna set our workstation based upon that folder that we just did. So D. Yeah. So I downloaded the 2 files, combats and Pokemon. We're gonna create a variable called combats equals read.csv, combats.csv, right? And then we also have another program called Pokemon.csv. So we're going to create another variable called Pokemon, read.csv, Pokemon.csv. So how do we look into our file without using Microsoft Excel? So what we're going to do is that we're going to type in head combats to look at the combats file. The read.csv automatically converts to technically a data frame, and the data frame is assigned to a variable called combats. By the way, can you guys hear me? I hope that's okay. But head combats is just, you only look at the first 10 rows of your data, first 10 rows of the file, basically. So right here, what we see is that there's the first Pokemon, the second Pokemon, and the winner. This is basically the whole file. The first column, the second column, and the winner. What this is this number is a unique identifier that represents a specific type of Pokemon. Pokemon unique ID number 266, Pokemon unique ID number 298, and who won against these against the 2 Pokemons? 298. Okay, since we have this, we have the battle, the combat data. That's fine and all, but that's like, we don't have enough information to do anything. So we have this battle. So what? So now we're gonna actually look at the Pokemon file, which contains probably, yep. all the actual Pokemon specific data. So you know how on the first file 266 266 would probably represent a certain type of Pokemon name, what type of Pokemon it is, what type of poison this is. So this second file is a reference to the unique ID numbers of the combat file. Does that make sense? So just to give you an example, damn, I'm a noob in my syntax. Attach Pokemon is just basically attaching the attribute names. I'll explain that later. So, you know what, I'll just explain it now. X dot name type 1, type 2. You don't have to, syntax wise, you don't have to. It just makes a lot of things easier. So you know how in the first Pokemon it says 266? I think it's where. I'm not sure though. Which? Oh god. Or let's see here. What if I could just do this? Oh, what up, Sean? How you doing? Oh, whoops. Oh, sorry. Oh, idiot. You're right. Man, I'm such a noob in R. If anyone knows the syntax of how to find unique ID under the X column of 266, let me know. But I think it's under, it's a which function? It's a which function? While, no which. Like this, wouldn't it? Can you do that? Or should I just do Pokemon $X? Or maybe I don't even need that. I already attached the Pokemon though, that's weird though. It should be like that. Let's see here. have sworn I just did this. So this doesn't work? Oh, I forgot the comma. Yeah, I'm an idiot. Sorry guys, that took a minute. I'm just learning R, but the structure is still the same. So just giving you an example. Remember how on the first Pokemon it's Pokemon ID, unique ID number 266. 266 corresponds with the Pokemon file Larvitar, type rock, ground 50, HP 50, attack 64, defense blah 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 blah, and legendary. So in SQL, in a data like it's basically a relational database concept pretty much. Your unique you have a column of unique IDs that are referencing another type of like basically table full of like the metadata that corresponds to the unique ID. In SQL terms, the primary keys to the foreign keys of X dot and stuff like that. But what do? Now that we've seen that that one file references the other file, I think what we can probably do is we're gonna actually put all of that data versus the other Pokemon data into one row. So X266 Larvitar with all this thing, and then we're also going to add 298, whatever that is, Nuzleaf, whatever, all into a single row of the data set. So now it'll just be a lot easier because then we have all of the attributes all lined up in a single row. So here's what I mean. I'm gonna kind of cheat a little bit because I kind of did this a long time ago. Let's join. Okay. I don't know how to do this efficiently, but I'm gonna do it the ugly way. In order for us to actually do that, all that metadata join into one huge ass data frame, yes, Jason. Yes, it is, Jason. Basically it is. With this skill set, you are giving a machine or software a method by which to interpret data to arrive at specific. Yep, that's very true. And it gives us insight to like which type of result matters, this one or this one. So, okay, so this is an actual phase. We're going to put all of this, the first Pokemon attributes and the second Pokemon attributes, all in one data frame that references these unique IDs. So it's gonna be, so what I'm thinking is that this data frame, it's gonna look exactly like this data frame, but with all the columns together. And then we have and then the winner at the end. This is actually very crucial. This thing is called a dependent variable, where in machine learning language, this is the actual prediction that we need to feed into a machine learning algorithm to predict the outcome. Okay, so we're going to merge or join the two opponent data into two opponent data into a data frame. How we do that? I'm gonna do it the dirty way. Number one, what we're gonna do is probably okay, so we have the first column, right? The first Pokemon on the first one. So what we're gonna do is extract just extract the first Pokemon out and then put that into a data frame of itself, just that one row, into its own data frame. I'll show you in a minute why. So first Pokemon equals combats first Pokemon as data frame combats the first Pokemon. So we did that. So basically this attribute, or this variable called first Pokemon, is its own data frame that consists of only the column of the combats. We're gonna do the same thing. See, like, so just to prove it, this is the index number, but this is the actual the first column. And we're gonna do the same thing for the second column too. So second Pokemon equals as.data.frame combats second Pokemon. And so it's fine. I'm not gonna populate everything, so I'm gonna just say second Pokemon. Yep, so this is the first 5 rows of another new data frame, a different data frame that only consists of columns of the second Pokemon extracted from the combat CSV file. I'll show you why in a minute. Oh, and keep asking me any questions, because I know this might fly way beyond you. If you guys don't know anything about machine learning or data analysis or whatever. So, what are we going to do with this? What we're going to do is, in R, there's a function called merge or join. Yeah. I just forgot the syntax. So our second step is to, so you have, you know all these columns, right? The columns of the data of the Pokemon ID. Now it's gonna be attach the corresponding ID to that other file using the join function. So merge Pokemon 1 equals join. Oh, what was the syntax? I don't want to cheat. Oh, that's right. Oh yeah, this is from a library called Kaggle. Oh come on, are you serious? Oh, plier, dplier. Oh, and I even typed it wrong anyways. There we go. I've imported this library called plier. It's something that you have to kind of download in R. The library is basically a toolbox of all these other special functions that you can use. It's a tool. And part of the tool that, in the toolbox, there's this thing called a join function. Undefined column selected. Oh, right. Oh, yeah. I forgot to name my column header. So that's okay. So call names. Next up. Whoops. Call names. First Pokemon is next up. And also, you would also have to do it for the second data set. So, merge Pokemon. Okay, now finally that's done. So, this is another data set that we just created. I think it's a data set. Where now we actually attached all of that metadata into the first Pokemon. So if you look at that, called merge Pokemon 1. Yep. So remember how in the beginning, like when we did the first Pokemon, the first columns, now it's attached with the metadata. And then we're gonna do the same thing for the second one. This is really ugly though. This method is really ugly, and I'm a noob. I'm pretty sure there's a way elegant, better, elite, amazing way compared to what I'm doing. That's why I'm such a noob in Kaggle, man. There's definitely a better way than this, but right now I kind of just want the results. And then once we do that, head Pokemon 2. Yep. So this is essentially the second column of the combats. Now, what we're gonna do is attach all of this and all of this. Now, I already see, like, you know, some confusion already. So before we even actually do the actual combining, we have to change this set of names into something else, because it's the same headers. So what we're gonna do is so what we're gonna do? Okay, so the merge Pokemon 2, we're gonna change the call names. The column names would be like X2. That would be the second Pokemon's unique ID number. Name 2. I'm just gonna put everything 2 at the end. If you have any like other suggestions on how we could tackle this, let me know. Whoops, I did this wrong. Hold on a sec. There we go. Now we can do. Yep, all the attribute names are different now that I changed it. So, what are we gonna do? Now we can merge, and that's a very simple process. So, it's gonna be new combat data equals cbind merge Pokemon 1 merge Pokemon 2. I hope that works. Oh hell yeah. New combat data. So we just created a completely new it's not really a data frame, it's more like just a vector, which is part of a data frame. There's kind of a data frame of the combined, basically just to combine information of everything. Now, the most important information that we're completely missing is the dependent variable from the combat data, but that's really easy. In fact, I should have just added that already, but I messed up. So combat. There we go. Now this is good. So this isn't a data frame, this is just a vectorized data structure. But I'm going to convert this into a data frame so that we can work on it a little bit better. Now we can do exploratory data analysis, I think. Yep. So we've attached combat's winner right here on this side right here. So that's really good. Jesus. So now we have completely combined this thing. I keep repeating myself, I'm sorry. Now we can probably do some exploratory data analysis. We haven't even gone to the machine learning language yet. But I think we already know what kind of data set that we're going into. It's either gonna be two Pokemon. Pokemon number 1 and Pokemon number 2. And the outcome is either 1 or 2, or 0 or 1. It's a binary outcome. So what machine learning language is like the most appropriate for that? It's a classification binary. Could we use logistic regression? Maybe. We could also use k-nearest neighbors for if it doesn't have a linear type of association between each data. But we still can't really conclude which type of algorithm that we want to pick. Because what if there's correlation between different datas, you know? Or what if there is certain types of things that certain columns that are actually really not that necessary? That's where EDA comes in, I think. So that's what we're gonna do, EDA. What are we gonna do? So now that we have the new combat data, we're going to actually say, all right, you know what? I'm gonna actually change. If anyone knows in R, how do you change a specific header? There we go. Let's see here, just see what it's out. Yep, change that to this. Sweet. Alright, now we're gonna do some EDA on this. You know what? What time is it right now? I think we're done for the day. It's already 15 minutes, so I don't want to like. I'm gonna finish this tomorrow. I'm gonna work on this tomorrow. The EDA part. It's gonna just be EDA and probably like which type of machine learning language. But right now, I think we're done for the day. I think we covered a lot. Or just an intro. We basically restructured the data so that it's actually useful for us. We combined all of the metadata from the first Pokemon and the second Pokemon and then the winner. So I think our new data frame is actually something that we can finally use to do some EDA. But what kind of EDA are we gonna figure out? We'll do that on our next stream. Alright man, peace on out guys. See you later.